यहाँ पर जो न्यूमेरिकल जिसके लिए हम शेयर स्ट्रेस डिस्ट्रीब्यूशन डायग्राम फाइंड करेंगे, that those will be for a symmetrical I section and a unsymmetrical I section. If the sections are symmetrical, so as you can see here, first one we have a hollow rectangular section. So this hollow rectangular section comes under symmetrical section. Okay, so for this symmetrical section, if you have to draw a shear stress distribution diagram, you will draw it in this manner. Okay, it will be in this manner. There will be Q1, Q2. For each there is a meaning of the stresses. So when we further solve the numerical, you will understand it. But first, just see which are the symmetrical sections and which are unsymmetrical sections. So first one we have hollow rectangular section, and channel section is also a symmetrical section. And for channel section also, the shear stress distribution diagram is similar to that of a hollow rectangular section. And we have a symmetrical I section. For symmetrical I section, again the shear stress distribution diagram, they're similar, right? So this T section here is now a unsymmetrical section. So for this unsymmetrical section here, the shear stress distribution diagram will be drawn in this manner. Okay, so as you can clearly see, if there is a flange, you will have a curve like this where you will have Q1 and then Q2, then the maximum, and then since यहाँ पर T के नीचे flange कोई भी नहीं है, तो it is coming directly to this point. So let us see how we can solve. After we solve the numerical, you will understand it. You will have to find each value of Q1, Q2, Q max. Okay, so let us start with the first numerical. A beam has hollow rectangular section with external dimension 80 mm into 160 mm and uniform thickness of section 10 mm. Draw shear stress variation diagram if section is subjected to shear force of 70 kN. Also determine the ratio of maximum shear stress and average shear stress. Now अभी यहाँ पर the hollow rectangular diagram of hollow rectangular section is given. If this diagram can be drawn after reading this numerical also, this statement also, but I'm giving it already here, so it should be simple and easy, but you try to draw your own diagram. Okay, and let us see how we can find maximum shear stress and average shear stress for this hollow rectangular section. Now as you should know that this hollow rectangular section here is a symmetrical section. So let us get going. So a hollow rectangular section as shown in the figure below is given. Now for this hollow rectangular section, we need to find shear stress distribution diagram, and then for this we also need to determine maximum shear stress and average shear stress. Now how do we do it? So let us first write down what are given from the question. So given we have shear force S equals to 70 kilonewton, which will be equal to 70 into 10 raised to power 3 Newton. What else is given? This is it. Now from here we need to find maximum shear stress. Maximum shear stress Q max question mark, then we need to find average shear stress. Okay, so now how do we start? To find Q max, which is maximum shear stress, Q max will be equal to find this Q max, it will be equal to q2 plus qadd. Okay, now how do we find this? The formula is changing here. Okay, so to find q2 we need to find q1. Okay, so let us get step by step. Let us go step by step so that you will understand it better. Now what is this qadd here? Qadd here is the additional shear stress due to web area. Okay, this is due to the web area. I'll show you where. So let us start by solving one by one. Now to find q1 I need to find to find q2 I need to find q1. Okay, so let me first start by finding its area, then moment of inertia and everything. Okay, so let us first find the area of this hollow rectangular section. Area A will be equal to, for this hollow rectangular section it is BD of the outer rectangle minus BD of the smaller rectangle. So how much is this? How much is B for outer rectangle? It is 80. How much is D for outer rectangle? It is 160. So 80 into 160 minus, for inner rectangle B is 60, and for the outer for the inner rectangle's depth it is 140 into 140. So from here you get this value equal to 4400 mm square. So this is the area. Now let us find moment of inertia. Moment of inertia about I-x axis will be equal to 1 by 12 BD cube of outer rectangle minus BD cube of inner rectangle, right? So from here what do I get? 1 by 12, B is 80, D is 160 cube minus, for the inner rectangle, 60 into 140 cube. Okay, so from here I get Ixx will come equal to 13.58 into 10 raised to power 6 mm raised to power 4. So now let us find Q average first. Okay, Q average, the formula for Q average is same, which is Q average is equal to shear force divided by area. Okay, now so how much is the shear force in the question? Shear force given in the question is 70. So 70 into 10 raised to power 3 divided by how much did we get area? 4400. So from here you're getting average stress equals to 15.91 Newton per mm square. So this is the average shear stress. Now let us find Q1. Okay, now Q1 here is shear stress at the bottom of flange. Okay, it is the shear stress at the bottom of the flange. So at the bottom of this flange will be this portion. I'm taking it as a flange for this section. Okay, ये portion, ये जो portion है, ये portion is a flange portion. Okay, so bottom of the flange पे find कर रहे हैं तो ये bottom ये होगा. So bottom का width कितना है? 80 है. Okay, so from here the formula to find Q1 is equal to S A y bar divided by BI. This is the formula. Now we know the value of S, area भी हमें मिलेगा, B भी मिलेगा, I भी we have got it. Now how do we find y bar? तो y bar किसका लेंगे? हम सिर्फ इतना पोर्शन का लेंगे, इतना पोर्शन. Okay, so how do we find it? So y bar will be equal to, ये न्यूट्रल एक्सिस से आपको जो डेप्थ लेना है, it will be from here till here. यहाँ से यहाँ तक का डेप्थ लेना पड़ेगा आपको, ये डेप्थ. तो ये डेप्थ कितना होगा? यहाँ ये न्यूट्रल एक्सिस है और ये इट इज़ द मिड पॉइंट ऑफ दिस फ्लेंज सेक्शन. तो इतना तक कितना होगा डेप्थ? What will be the depth? So total from here to here is 80. So I can take 80. अब मुझे ये पूरा टोटल 80 है और यहाँ से मुझे माइनस करना है इतना ही. तो इतना कितना है? The thickness of this wave is 10 mm. So 10 mm का हाफ पे एक्ट कर रहे तो -10 divided by 2. So from here you get 75 mm. The other way to find this is by considering this inner rectangle. Okay, inner rectangle का यहाँ से न्यूट्रल एक्सिस से यहाँ तक का, अगर न्यूट्रल एक्सिस से ऊपर ये जो छोटा ट्रायंगल है उसका यहाँ पर हाइट यहाँ तक उसका 70 mm है. So if from this neutral axis below the neutral axis till this point, the height will be 70 mm because the total height of this inner rectangle is 140, right? So this will be 70. So you can take 70 plus you are coming from here till here, and then now you need to take half of this. So plus 10 by 2. This will also give you 75 mm. Either way, you are finding the distance from this neutral axis till this point. Okay, so now we have all the values. Now let us find Q1. So now Q1 will be equal to S is 70 into 10 raised to power 3, area is 4400 into y bar is 75 divided by B. Now this B will be the width of this flange, total width of this flange. So how much is total width of this flange? It is 80 into I, we got 13.58 into 10 raised to power 6. Now here, from here you get Q1 equals to 3.864 Newton per mm square. Okay, now from here we can find Q2. Now from here Q2 will be equal to Q1 times, now जब हम ये Q2, what is Q2? Q2 is shear stress at the bottom of flange by taking the width. अब ये shear stress at this bottom ही है, bottom पे ही है, but अब जो width ले रहे हैं हम, ये width पहले Q1 के लिए हमने पूरा width यहाँ से यहाँ तक लिया. अब ये Q2 के लिए हम सिर्फ width इतना लेंगे, इतना, this width here this much and यहाँ का this much, इतना ही लेंगे हम. ओके, तो ये width कितना होगा? इतना, it is 10 and this is 10, so 10 plus 10 is 20, right? So the total width is 80 divided by जो हम actual ले रहे, that this is only 20, 10 plus 10, so here we have 20. ये 80 कहाँ से आया? ये total width. और ये 20 कहाँ से आया? 20 from this width. Okay, so this will give you equal to Q1 कितना मिला था? 3.864 into 80 divided by 20. So from here Q2 you will get equal to 15.9 456 Newton per mm square. So this is Q2. Okay, now we found Q2. Now we can easily find Q max, right? So Q max, oh, not yet, we cannot find. We need to find Q additional first. So let us find Q additional. Qadd will be equal to SAY bar divided by BI. Now यहाँ पर जो y bar लेंगे, this Q additional here, Q add here is the additional shear stress due to web area. Now web area कौन से consider करेंगे? Web area हम ये consider करेंगे, web. Okay, web area will consider this portion here, यहाँ से यहाँ तक इसको हम web consider करेंगे. Okay, from ये inner rectangle का जो है उसका height तक, यहाँ से यहाँ तक, this will be the web portion. इतना we'll consider it this much. Now इसके लिए y bar, how much will be y bar? Y bar for this portion, for the web portion, y bar for web portion, this web portion will be coming equal to up. What we will take, यहाँ पर neutral axis is running from in between, right? अब neutral axis के ऊपर हमने consider किया तो यहाँ से यहाँ तक का we have one section, इतना one section है हमारे पास, इतना we have this much section, right? Above neutral axis इतना section है. तो इसका आधा पे consider किया तो कितना होगा? हमें सिर्फ इतना y bar, ये चाहिए हमें y bar web portion के लिए. तो ये कितना होगा? It will be 70 divided by 2, which will come 35 mm. So now let us find Q additional here. Q additional here will be, S will be 70 into 10 raised to power 3 into area is 4400 into y bar is 35 web portion के लिए divided by, now B कितना लेंगे? How much will you take B for this web portion? इसका B यहाँ से यहाँ तक कितना है? It is 10, right? यहाँ से यहाँ तक का it is 10 और यहाँ से यहाँ तक इस पे दो वेब है ना, एक यहाँ पर है, ये पोर्शन पे वेब है और दूसरा यहाँ पर है वेब. तो यहाँ से यहाँ तक का 10 और यहाँ से यहाँ तक का 10. So 10 plus 10, 20. So B here will be 20 into I will be the one that we found, 13.58 into 10 raised to power 6. Now from here you will get Q additional equal to 12.622 Newton per mm square. Okay, now आपको Q2, you have found Q2, you have found Q additional, now you can find Q max. So from here Q maximum will come equal to, how much is Q2? Q2 is equals to 15.456 plus Q additional is 12.622. So this from here you will get equal to 28.078 Newton per mm square. So this is your maximum shear stress. Okay, now if you are asked to find the ratio, so ratio will be, you will find ratio as ratio of Q max divided by ratio of Q average. So Q max you got 28.078 divided by Q average, how much did you get? 15.91. So 15.91. So So from here you get the ratio equal to 1.765. Although ये क्वेश्चन पे आस्क नहीं किया है अभी, ये क्वेश्चन के लिए रेशियो फाइंड करने के लिए नहीं बोला है, but if in case you need to find ratio also, then you can find ratio in this manner. Okay, now let us draw the shear stress distribution diagram. For this hollow rectangular section, flange portion है, right? तो we will draw a imaginary line. पूरा यहाँ से imaginary line draw करेंगे. यहाँ पर एक वेब है, वेब फ्लेंज पोर्शन, यहाँ पर भी एक फ्लेंज, यहाँ पर एक फ्लेंज है, नीचे एक फ्लेंज है. तो यहाँ से ड्रॉ अ स्ट्रेट लाइन. जब जहाँ पर फ्लेंज पोर्शन है वे पोर्शन पे आप यू टेक इट लाइक दिस, और नीचे भी यहाँ पर यू हैव अ फ्लेंज पोर्शन, ये पोर्शन पूरा फ्लेंज है, राइट? तो इसके लिए भी यू टेक इट लिटिल बिट लाइक दिस. देन आफ्टर दैट जब ये बीच के पोर्शन पे आते हैं जहाँ पर स्मॉल रेक्टेंगल है, उसके लिए यू गो स्ट्रेट. ओके, यू गो स्ट्रेट. ओके, और मैक्सिमम फिर अगेन इट विल कम एट दिस पोर्शन ओनली. तो यहाँ से इट विल बी गो टू मैक्सिमम and then it will come down. So this will be the diagram. Now this point here is your Q1 जो हमने मिला था. How much did we get? Q1 came equal to 3.864. So we have 3.864 Q1 and Q2 portion will be at this point. Okay, so this is Q2, which you got 15.46. So here also you have Q2 and here you have Q1. Now जो ये middle का portion है, here you will have Q maximum, okay, which came 28.078. Now what is this? This is a shear stress distribution diagram. Shear stress distribution diagram. Now when I was writing the values of Q1, Q2 and maximum shear stress, I did not mention the unit. तो जब आप ऐसे लिखते हो तो you can mention shear stress distribution diagram in Newton per mm square. So you can mention the unit here. Okay, so I hope this numerical is clear. Let us solve the last numerical for today's session. This is the channel section here, and this channel section is also a symmetrical section. So let me read its statement. A channel section as shown in the figure carries shear force of 100 kN at a particular section. Calculate the ratio of average shear stress to maximum shear stress. Now here we need to find the ratio. So to find ratio, it is said that ratio of average shear stress to maximum shear stress. Okay, so let us see how we can find the ratio here. And to find the ratio, we need to find average shear stress and maximum shear stress. So ये ऐसे channel section के लिए average and maximum shear stress how we can find? Let's see. Let's get started with this numerical. For this channel section, the figure is given and its dimension is all given. So from the question, we have to find, from this diagram, we need to find the ratio of average shear stress to maximum shear stress. So the given in this question for now is shear force S is given equal to 100 kilonewton, which will be equal to 100 into 10 raised to power 3 Newton. Okay, and we need to find the ratio. Now let us get started. Let us first start by finding the area of this channel section. So area A of this channel section. Now if I convert this as 1 2 and third section, 1 and 2 have the same dimension, right? So this 1 and 2 are flanges here, so these flanges have same dimension. So 2 into 80 into 20, this is the area of these two flanges, plus now area of this web portion, only this much. It will be equal to, what is this height from here to here? 80 plus 80, 160. 160 into the thickness of this web is 20. So from here area will be coming equal to 6400 mm square. Okay, now let us find the moment of inertia I xx. Now if I convert this into a hollow rectangular section, I'll have 1 by 12 bd cube of outer rectangle minus bd cube of inner rectangle. So from here I'll get 1 by 12 outer rectangle. For outer rectangle, b is 80 and d is 200. So I have 80 into 200 cube minus, for the inner rectangle, this is the inner rectangle and this here is 20. So 80 minus 20 is, b is 60, its depth is 80 plus 80, 160. So 160 cube, right? So from here Ixx will come equal to 3.285 into 10 raised to power 7 mm raised to power 4. This is moment of inertia. Now let us find shear stress at bottom of flange, which is Q1 equals to shear stress at bottom of flange. Okay, so this Q1 will be equal to SA y bar by IB. So this will be coming equal to, तो ये कौन से पोर्शन है? ये पोर्शन पे, राइट, बॉटम ऑफ द फ्लेंज यहाँ पर. तो यहाँ तक हमें कंसिडर करना है. तो इट विल बी इक्वल टू एस गिवन इज 100 इंटू 10 रेज़ टू पावर 3 इंटू, अब एरिया कितना होगा सिर्फ इतना पोर्शन का, इट इज़ 80 इंटू 20, राइट. सो 80 इंटू 20 इंटू वाई बार. अब ये न्यूट्रल एक्सिस से वाई बार लेते हैं तो इसका सिर्फ आधा, ये पोर्शन का आधा तक आएंगे. सो दिस मच विल बी वाई बार. तो हाउ मच विल दिस बी? फ्रॉम हेयर टू हेयर इट इज़ 80 and half of this section will be 20 by 2 which is 10. So 80 plus 10, 90. So 80 plus 20 divided by 2. This will give you 90. Divided by I, we got 3.285 into 10 raised to power 7 into B. B kitna hai? It is 80 into 80. So from here you will be getting 5.479 Newton per mm square. Okay, now similarly let's find shear stress at the web portion, right? So Q2, shear stress at web. Okay, so shear stress at web portion will be equal to Q2 will be equal to Q1 plus. Now I need to, since I said web, I need to take this portion only. इतना section नहीं लेना पड़ेगा, इतना. So what is the depth of this section? It is 80, right? what is the total width from above? This is the junction in between web and flange. Okay, so ऊपर B flange का B कितना था? It was 80. It was 80 divided by thickness of this web is 20. So from here I have 80 by 20, right? Now Q1 कितना मिला है? Q1 came equal to 5.479 into 24 is 80, so into 4 will give you 21.92 Newton per mm square. So this is Q2. Now let us find additional shear stress. Additional shear stress due to web area above neutral axis. So this will be coming equal to SA y bar by IB. और ये कितना होगा? आपका S कितना है? 100 into 10 raised to power 3 into area. अब एरिया कितना होगा? एरिया सिर्फ आपको ये न्यूट्रल एक्सिस के ऊपर का वेब का एरिया लेना पड़ेगा. सो फिर वेब यही आएंगे, ये पोर्शन. न्यूट्रल एक्सिस इज हेयर, न्यूट्रल एक्सिस के ऊपर के वेब पोर्शन का लेना पड़ेगा. सो दिस इज द वेब पोर्शन, राइट? सो इसका एरिया कितना आएंगे? दिस शेडेड पोर्शन हेयर एरिया विल बी 80. Depth from here to here is 80 into thickness is 20. So we have 80 into 20 into y bar. Now half of this section itna ka y bar. So it will be 80 divided by 2, which is 40. Divided by IXX we got 3.285 into 10 raised to power 7 into B. Now how much is this width? Web portion ke? It is 20. So into 20. So from here you will get equal to 9.74 Newton per mm square. Now if we find maximum shear stress, Q max will be equal to Q2 plus Q add. So how much did we get? Q2 came 21.92 plus 9.74. 9.74 is Q additional. So this will give you value equal to 31.66 Newton per mm square. Now how do we find Q average? Q average will be equal to shear force by area. Shear force is 100 into 10 raised to power 3 divided by area. We got 6,400. So from here you will get shear stress equal to 15.625 Newton per mm square. Okay, so now let us find the ratio. We are asked to find the ratio. So ratio will be Q average divided by Q max. So average, how much did we get? 15.625 divided by Q max is 31.66. So this will give you ratio equal to 0.493. So this is the ratio. Okay, so we're just asked to find the ratio. So I hope this numerical is clear. So I'll see you in next session.